some problems. I'm specifically going to go over that was. Okay, we're going to use this graph, and we're going to answer these questions. Okay, so I'm not going to go back and forth. I'll just read them and show you again, and we're going to hook this in. Okay, let's get a little hook in. Whatever that means. Okay, so we're gonna record on this bad boy too. So I'm gonna recreate this graph that we have. 4 and 3, 2, 1, 0, and -4. And we're gonna do a little, you got pi over 2. We've got 3 pi over 2. We've got 2 pi, 5 pi over 2. So these are, I'm not going to get as much of the graph as the original picture has. These are polar coordinates, because it is going around a circle of pi, because pi's are circles. So this is the graph that we've got, okay? This is some form of a sine / cosine, whatever curve. And I know it's curving weird, but whatever. So what we're trying to do, excuse me here as I make an adjustment, adjustamundo, is we are being asked to figure out some function stuff. So first question is, what is function at 0? Function at 3 pi over 2? Function at 3 pi, question mark. Then the next question is domain and range. And I'll actually just use what I have here instead of what the original problem was. Then the question is, we want to look at the intercepts. And then we have a question like, how many times does y equal 2 intersect? Okay, so these are relatively simple. Let's get a new color. These are relatively simple, but we've got to figure out, we're using this graph, okay? So sometimes you have to iterate the graph, and sometimes you're given the graph, and I hope you can see this, okay? My thing keeps slouching. I get a slouchy go-go arm here. So the function at 0, this is the function. Now remember, this is always going to be x, and this is always going to be y. And y is the same as the function of x, okay? Can you see it up there? So y function of x and x. It is always going to be this way because of the fact that x is synonymous with the horizontal, f of x the vertical, although it is very important still to label your graphs. So the function at 0, this notation is when x is 0. That's the origin. So what is the value of the function when this is 0? Well, it's up here, right? It's equal to 4. Now, similarly, function at 3 pi over 2. All right, well, 3 pi over 2 is right here. And the value of the function, this direction, now we go over here. Survey says it's equal to 0. Equals 0. 3 pi, okay, I know I've got bad handwriting, but we find 3 pi over here. What is the value of the function? It's down there. It is -4. Okay? That's how you find that. You just pull it out of the picture. We are learning the language of the graph. This is a picture that has value. Okay? How many times do you have people say right now to you, oh, follow the data. Data-driven decisions. Do you know how to read the data? Because if you don't know how to read the data, you are just as susceptible to being lied to as someone who does know. It's just, you got to know what you're talking about. Okay, so domain and range. So the domain is what we put in. What is the value? What do we go to with x? Well, there aren't any gaps. This is a continuous line. So that means our domain goes from 0 to 3 pi in our picture. So we're going to write that. We'll do that in very fancy notation. So you'd use brackets to mean inclusive. So 0, 3 pi, inclusive. Okay, and just for the record, if you want to know, this means the same as this. 0, or equal to x or equal to 3 pi. Okay, you could also say the domain is all real such that, and then write this, x is meaning, and that means it's continuous, okay? But this thing with the brackets, this bracket means or equal to, okay? It means or equal to. It's kind of fun. I need another color. Thank you. This bracket is or equal to. Versus this, if you had like this, let's see you had this. Okay, you're seeing this over here in orange. That would mean 0 less than x less than or equal to 3 pi. Okay, so the square bracket means or equal to. The open regular parentheses means just less than or greater than. Back to red. Okay, so what is our range? Back to our equation. The range of the y values. So we actually don't need to, we don't care how far along it goes. We care what these bounds are. And in this case, we get to 4, repeatedly get to 4. And we also go down to -4. Okay? So our range is going to be, and it's continuous, -4, 4. And again, we use the brackets based on this definition. Okay? What are the intercepts? Okay, we were vague on that. We didn't say if they were x or y. We're going to say the x-intercepts are all these spots, right? Pi over 2, 3 pi over 2, 5 pi over 2. The y-intercepts, the only place it crosses the y-axis or comes in contact is up here. Sorry, I'm not sure you're not seeing that. It's at 4. So we'd say when x is 4, we've got a y-intercept. Okay, last question. How many times does y equals 2 intersect the graph? Well, here's y equals 2. Okay, we've got to draw the line. Y equals 2 is a horizontal line. That's y equals 2. So we aren't asked where, although we might have to find these a different day, but how many? So that'd be, of course, 1, 2, 3 times. 3. That is our problem. Okay? You see the totality of this? That's the problem. And then that's all that we have to do. It's an easy one. It's a relatively easy one. Okay, let's think about now other types of graphs, other types of functions. So let's think of this function here. F of x equals x plus 1 over x plus 2. Okay, are you seeing this? And we want to know, so first of all, what is the domain? Okay, what are you allowed to put in? Well, this is a tricky one because we've got this. We've got a denominator with the variable in it. Okay. So you say, well, what are we allowed to put in? What is the one number you cannot divide by? Because it's a division, of course, right? What can you not divide by ever? It doesn't. The universe implodes. It doesn't make sense. You cannot divide by 0, right? So you cannot have x plus 2 cannot equal 0, okay? We're saying how this, so we take the whole denominator and we say this can't be 0. And now we solve this with the cannot equal. X cannot equal -2. But it can be everything else. So the domain is going to be all real. That's the symbol for all real. But x cannot equal -2. There you go. I'm getting the phone calls all over the place, so I'm trying to figure out what that is. That's okay. Let's do this problem and then I'll figure that out. Now the next question is the point 1 1/2 on the graph? Okay. So question: is 1 1/2 on graph? That's the question. Okay, this is a pre-calc level function stuff, okay? So I say it that way because like everything in math, or you regurgitate the same things, right? It's like you can be in 5th grade and know the rules of basketball, but it's a very different game if you're playing in high school or if you're playing in the NBA, right? So this is functions, but it's like sort of pre-calc, algebra 2 /trig /pre-calc level functions, okay? We're not doing basics right now. So the question is 1 1/2 on the graph? Well, another way of saying on the graph is saying if I plug 1 in for x, is my solution 1/2? Okay, so that's the question. So what we want to do is we're going to put 1 in for that. So we're going to find function at 1 is equal to 1. Let's actually let's do the original thing, right? We have, let's erase this. We have, the original thing is x plus 1 over x plus 2, and that's the function at x, right? But now watch, we want to know the function at 1. So we erase the 1 there, we erase the 1 there, we erase the 1 there, and we put in 1, okay? The function at 1 is this. 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 2 is 3. So when we put in 1, we got out 2/3. So does that mean, is this on the graph? No, because we wanted 1 1/2. No. Our function at 1 is 2/3. It's not 1/2. So it is not on the graph. Hard pass. Okay. Next question is the exact same idea asked a different way. If x equals 2, what is the function? Okay. And then secondary to that is what is the point of the graph? Okay. On the graph. So this is 2 ways to ask the same question. What is the function of x? What is the point on the graph? So the function is the y part, and then the point on the graph is 2, whatever that is, right? We're going to do it the exact same way. It's just asked a different way. So we go back to our function. I'm going to put this in red, just so we make sure that we know what it is. Function of x is equal to x plus 1 over x plus 2. But we now want to specifically know what the value is. Let's do another color for funsies. What is the value when x is 2? Okay, so we're going to erase this, and we're going to put 2 in for that. 2. Ooh, the lime green is hard to see. I'll have to change that. Although it's a fun one, it's got to go. It's got to go 2, 2, 2. Okay, f of 2, 2 plus 1 is 3. 2 plus 2 is 4. So the function of x is 3/4, and the point on the graph is 2, 3/4. Okay, that's the point. So we're asking the same process a lot of different ways. How can you score a basket? Well, I could do a layup. Awesome. What happens if you shoot a jump shot from the 3-point line, right? Can you make a free throw? That's what you're doing on repetition, okay? Now, we're going to ask one last question. We're going to ask it a different way, and it's going to be our last one. It's a little harder, okay? We're going to ask the reverse question. If the function is 2, what is x? Oh, okay. So what you're saying is, what if this is 2? Well, let's go back to our original function, okay? I'm going to put it in red again. F of x is equal to x plus 1 over x plus 2. Well, now we are erasing and replacing this, and we are making that 2. Should be a completely different color, just to prove that we did. We'll make it purple. Can you see purple? I don't know. 2. So now we need to solve this for x. And now we're bringing out our super fun algebra. So you got to get this out of the denominator, multiply both sides by x plus 2. Again, this is pre-calc level stuff, so I'm going a little bit fast. Pause it if you need to. This is x plus 2 over 1. That's x plus 2 in the denominator. Those cancel. So on the one side, you have 2. X plus 2 equals x plus 1. I am allowed to do this because of the commutative property, or excuse me, the associative property of multiplication, where it doesn't matter the order. That equals x plus 1. So now let's use the distributive property, right? 2x plus 4 equals x plus 1. We can subtract x from both sides, and we get x plus 4 equals 1. Now we're going to subtract 4 from both sides, and we're going to get x equals -3. So when the function equals 2, x is -3, or the point is 3, 2. And in fact, once more into the breach, dear friends, we can confirm this with our original equation, f of x equals x plus 1 over x plus 2. We're going to plug negative 3 in to see if we get 2. Negative 3 plus 1 over negative 3 plus 2. That equals negative 2 over negative 1, which equals positive 2. Ka-da-ka-da-ding, bada-boom, bada-bing. I am excited because I just got this stylus. So that's how we roll. I'm going to do more later. I clearly need to get back to whomever is around. Please throw in any questions you might have. We are going to be going over functions this week. Look for the lessons. I will see you out there. Danke Shane, darling.